Okay, gentlemen, today we're going to look at the third way to solve a quadratic equation. The first way being factor if you can. We did a lot of work with factoring, so factoring is definitely our primary method here. We learned yesterday about completing the square and how to kind of make the left-hand side become the product of two identical binomials. And then we kind of just solve for x from there by square rooting. Today we're going to see how that relates to our next method called the quadratic formula, which some of you may know. Okay, so we're looking here. This was a problem we did yesterday in class from the textbook. I started it for us. 4x squared minus 20x plus 17. Move over the 17, divide everything by 4. X squared minus 5x equals negative 17 over 4. Now, as we mentioned in class, if I take the b value, my negative 5, I divide that by 2, and I get an answer, which in this case I can't do anything. And then I square it. That's the number I'm going to add to both sides. The b, once I move over my c and divide by a, divided by 2, n squared, is what I'm adding to both sides. We want to do that, and that's when we're doing that, we're going to try to get a binomial times a binomial with all identical terms inside so that I can rewrite that as a binomial squared. I did the adding over here, negative 17 over 4 plus 25 over 4. Common denominators, negative 17, positive 25. There's my 8, which we know is 2. So I kind of just throwing that in there. But over here, I chose negative 5 over 2, the b, divided by 2 squared, to add that to 25 over 4 to both sides, because every time I do that, this value, in other words, the b over 2, before I square it, the 25 over 4, before I square it to get that number, that is what's going to go right in here. So it's just minus 5 over 2. That's what's going to go in there. So with the even numbers, it was very easy to do that, because if I had 6, it was very simple to look at that, get the 3, and then kind of look at it. It's like, oh, 3 and 9. With odd numbers, it's harder. So my b divided by 2, remember that number, squared, 25 over 4 is what I add to both sides. When I have to factor that into a product of identical binomials, it's going to be the b divided by 2 prior to me squaring it to get the 25 over 4. So now I can rewrite that as x minus 5 over 2 squared equals 2. And we saw this in class, and this is the same method here throughout. Divide square root both sides, so I get the squared to go away. Very important, I get my plus minus. You're definitely getting plus minus because I am doing the square rooting, and there are two values that can get me to square root of 2. I add 5 over 2 to both sides, plus 5 over 2, and I have my result of 5 over 2 plus or minus radical 2. In other words, x is equal to 5 over 2 minus 2, and x is equal to 5 over 2 plus radical 2. So the key here is when you have an odd number as your b value, divide that by 2, remember the number. When you square it, that's what you're going to add to both sides. What you had before you squared it is going to go right in here. It's going to be right in there. Whatever minus that b over 2 as a binomial squared is going to be is always what that's going to factor to. When you complete the square, it's always going to be that number. So nice little trick to kind of help us do that. And that's important for what we're going to do next. Again, these are my two zeros or my two roots. If you notice, they're very similar. One's plus one or one's plus one's minus, but it's the same first term, the same second term, one's plus one's minus. And if we graph it, you'll see that those are my x-intercepts, whatever those decimals are. Okay? Now let's say I were asking you to solve the following general quadratic equation. A, B, and C are all some real number. I don't know what they are, but it's some real number. Okay, so let's do that. Let's start with that. So same steps. We're going to complete the square. Step 1, move over my C value. So the first thing I'm going to do is move over my C value. AX squared plus BX is equal to negative C. Second step, divide every term by A. We said if it's not 1, if it's 1, you can leave it. We don't know what A is, so we got to divide by that. I like to sometimes write it like this, right? So the B over A is the coefficient of the X is equal to minus C over A. I like to write the minus in front. Okay, so now here's my 1. Here's my B over A, which is the coefficient of the X. And then here's my negative C over A, or negative C over A. Okay, now just as we saw up above, I take my B value and I divide it by 2. So B over A divided by 2. And then I'm going to square that. We learned right at the very end of last trimester, when I have a fraction divided by a fraction, keep, change, flip. Keep, change, flip. So I would have B over A times 1 over 2. In other words, B over 2A. I'm going to square that, but remember, we want to recall this number later on. This number, or these terms, this B, this divided by 2A is going to represent a number for us. That thing is going to come in handy later, as we saw up above. I'm going to get, when I square that, B squared over 2A times 2A is 4A squared. So I took my B, which I had to divide by A, divided that by 2, I kept, changed, flipped, multiplied, B times 1, A times 2. Then I squared it, B squared over 4A squared. I got to remember this. It's going to come in handy later. This B squared over 4A squared is what I'm adding to both sides. X squared plus B over A x. I'm adding B squared over 4A squared to both sides. Equals, I'll slide this over a little bit, negative C over A plus B squared over 4A squared. Okay. Now, getting tricky here. There's a lot going on. I took my B, which was B over A, divided it by 2, and squared it. And that's what I'm adding to both sides. So B squared over 4A squared, B squared over 4A squared. This is very hard to factor. How am I going to know how to factor this? Well, just as we saw up above, I know this is going to be, it's plus, because that's plus, x plus whatever I had, b divided by 2, before I squared it. So here's my b over 2a. Right? Once we know that trick and we practice it, we can see that here. We can use that here. It's b over 2a. Okay? So it's hard to, we're not going to know how to, I can't show you how to factor this. Like what two numbers multiplied, it's hard to see that. But if you notice, b times b would give me b squared. A times 2a would be, and this is squared, right? So it's 4a squared. That's what I get it from. Right? So b times b, 2a times 2a. And when I subtract them, they cancel. Okay, equals, I gotta add these. Very annoying because I don't have a common denominator. I have to go get a common denominator. Why are you making me do this? C over A plus B squared over 4A squared. this guy needs, in order to match, I'll do it in orange so it stands out, a 4 and an A on top and on bottom. So I'm beefing up the left-hand side so that I get it to match the fraction on the right. Negative 4AC over 4A squared plus B squared over 4A squared. Now that I have common denominators, I can write negative 4AC plus B squared all over this 4A squared. So that side job was just so that I can write this. Actually, got to move this over a little bit. Plus B squared all over 4A squared. That little side job was just to get a common denominator, just so I can write it as a single fraction, because I want it to be a single fraction. Right, so this whole mess, taking your B, dividing it by 2, remembering that number, squaring it, you add the squared thing to both sides, and that's what you factor it to. Okay, now we do our regular steps from here. You're square rooting both sides, and you're like, how is this going to come out nicely? I know. Here's my x plus b over 2a. Square rooted both sides, so the square root and the squared cancel, okay? Equal to, now we know when I have a square root and a fraction, I can split it up on top and bottom. Will that help me? I don't know. Here's my negative 4ac plus b squared over square root of 4a squared. Okay, so I radicaled the whole thing, and I said I'm going to break it up. Maybe I can split some stuff up. Top. Can't do any breaking down. Oh, wait, but there's a b squared. You told me when there's a squared in a square root, they cancel. You're right, but there's a plus sign. This plus sign ruins everything. I cannot break up part of this in a radical when there's a plus sign. These are two terms. I can only simplify monomials, single terms. So just this. Once this is added, broken, no good. Just this. Once this is added, broken, no good. But the bottom, that's a monomial. 4 times a times squared. Wait a minute. 4 is a perfect square. Wait a minute. A squared's a perfect square. Wunderbar. I can cancel out this nice bottom over here and give me just my negative 4ac plus b squared. The bottom comes out of a radical. How wonderful. And if you notice, that 2a has been floating around for quite some time. If I was over here as b over a divided by 2 times it by a half. That's what that means. Here's my 2a. I squared it, did all this mess, and then I square rooted it. So it came out. Very nice. Now we got to continue with this. Minus b over 2a minus b over 2a. I subtract from both sides the same. I get x is equal to, this was also a plus minus. My bad. This was a plus minus way in the beginning. Plus minus. I took this out. Okay, so now I have my plus minus, my radical, negative 4a, this was a c I forgot to write, plus b squared all over 2a minus b over 2a. Wow, how nice. There's a 2a here and a 2a here. No need to get a common denominator. They are a common denominator. I'm going to write this negative b in front. Why am I doing that? Because maybe you'll recognize what I'm writing here. Negative b plus or minus radical. I'm going to rearrange this in here. B squared, which is positive, minus 4ac all over 2a. And you may be sitting there, if you had a nice, good 8th grade teacher, saying, Shiza, this literally is the quadratic formula. We just derived the quadratic formula from this whole mess of completing the square. Yes, that was the point. You take this regular generalized quadratic equation, you complete the square, and you figure out the quadratic formula. So when you do the quadratic formula, You're completing the square without doing the steps. You have a choice to make now. When you are given a quadratic formula that you cannot factor, you can either do the steps of completing the square or memorize this formula, plug in your A, your B, and your C, and you just kind of skip the steps and you memorize the formula. Either way, you either memorize a formula or memorize a group of steps. Same difference. Okay, so let's do 2 examples. Let's start with this one. This example, well, looks very familiar. It's from Async 2.2 or 2.02. That's where it's from. We know the answer. If you go look back at your notes, I know the answer. I know what it's going to be. We did it in our async last time. We should get -1 plus or minus radical 19 over 2. And that we did by completing the square. Let's do it by the quadratic formula. We have to get the same thing. I'm not going to do it out, but 1, can we factor this? No. 2 numbers that multiply to -60 that add to +8. The 60 coming from the -15 and the 4. And we know that there are none. If you do it out, you won't be able to do any. Option 2, we could either complete the square or the quadratic formula. Either complete the square or the quadratic formula. We're going to learn about the quadratic formula today. A is 4, B is 8, and C is -15. Yes, the signs matter. Yes, if you pick a wrong sign, you'll get the wrong answer, so just be careful. Okay, so my formula, which we would eventually have to memorize, is x is equal to -b plus or minus square root of b squared minus 4ac all over 2a. Okay, so let's plug it in. -8 plus or minus square root of 8 squared minus 4. The a is another 4. The c is a -15. Divided by 2 times the a is 4. So all I did is take my formula, which I rewrote over here, plugged in a everywhere I saw an a, b everywhere I saw a b, and the 15 everywhere I saw a c. And all we do now is solve. -8. What's 8 squared? 64. Now be careful here. This sign is the only thing that trips people up. -4 times 4. -16 times -15. That is, I don't know. Let's pull out a calculator. I have no idea. 16 times 15 is negative or positive 240. -16 times -15 is positive 240. All over 8. Now again, you cannot cancel these 8 because there's a plus or minus sign here. We have to have a number constant in all terms. So let's keep going. -8 plus or minus radical. What's 240 plus 64? 304 divided by 8. Okay, now as we learned with radicals, we always have to try to simplify the radicals. Okay, so we got to simplify this 304. I know this can be broken down into a 19 and a 16. 304 divided by 19 is 16. So I can write this as -8 plus or minus, the radical 16 would come out as a 4, radical 19 all over 8. I did that a little fast because I don't want to spend time breaking down radicals. Just, you would have to do it by hand, right? But I know that 16 times 19 is 304. Now, I have a term, and a term. An 8, a 4, and an 8. They all have something in common. 2, 1, 2. I can rewrite that as -2 plus or minus, what did I do here? Yeah. radical 19 all over 2. Right? And just as we had the other day in async 2.2 or 2.02, if I wrote this as negative 2 over 2 plus or minus radical 19 over 2, I would get negative 1 plus or minus radical 19 over 2. That is the exact same answer as that. Just as expected, I get the exact same irrational, but real, but irrational answer. I have two results here. One is negative 2 plus radical 19 all over 2, and the other one is negative 2 minus radical 19 over 2. Or in other words, you can write it as negative 1 plus radical 19 over 2, or you can write it as negative 1 minus radical 19 over 2. Right? So these are the same, these are the same. These are the two answers, these are the two answers, and they're just written in two different ways. Okay, so again, quadratic formula is doing complete the square by memorizing a formula versus memorizing steps. Let's do one more example. I'll do it a smidge faster. We don't know what the answer is going to be here. The key with these is you want everything to be on the same side. So just as we have been saying for a long time, always get it to equal 0. Now we can decide, can I factor? If I can, that's definitely preferred. Two numbers that multiply to 9 and add to negative 7, none. 3 and 3, 9 and 1, no and no. So let's do the quadratic formula. My A is 3, my B is negative 7, and my C is 3. And I'll circle those for us. Here's my A, here's my B, here's my C. Negative B. Be careful with that negative sign. You have to remember that that negative sign is this negative sign is in there. There's a negative in front of the B. It's negative B plus or minus square root of B squared minus 4AC all over 2A. And that formula will have to be memorized. I'll write it down up here. Negative B plus or minus square root of B squared minus 4AC all over 2A. Again, it's x equals. Because you're solving for your roots, your zeros. Okay, so 7, now it's positive. Nice. Plus or minus 49 minus 4 times 3, 12, times 3, 36, all over 2 times 3, 6. X equals 7 plus or minus square root of 49 minus 36. Well, that's 13 over 6. Cannot break down 13 at all. Nothing can come out. 7 and 6, even if I could factor or cancel something, no, I need it to be outside the radical 13 as well, and there's nothing. So I have two answers, 7 minus radical 13 over 6, whatever that is, and 7 plus radical 13 over 6. These are my two answers. 2 roots, 2 zeros. I was unable to factor because nothing factored, so I had a choice to make, either complete the square or the quadratic formula. The quadratic formula is the steps of complete the square by filling in, by plugging in. Plug and chug. Over here is follow the steps and you'd get the same answer. Okay, so gentlemen, go look at your 3 problems to do for homework. This was a longer video just explaining where it comes from. It's important to realize that complete the square is the quadratic formula. Your steps are always factor if you can. If you can't, either complete the square or the quadratic formula because they're the same. They are the same. It's just plugging in and going, or steps and answer. Either way, you'd have to memorize the steps or memorize the formula. Total preference on your part. Okay? Do the classwork, the async, by doing the quadratic formula so we can practice it. Okay? Have a good day.